Let us do some more good problems. First is this question. Guys, first I give you 1 minute. Try to do it by whatever method you want to do. Shortcut or definition, whatever you feel like, just do it. इतना सोना क्यों रब ने बनाया, इतना सोना. I'll suggest to begin with, first we apply standard definition. Find LHD, find RHD at 0, and try to see if they are equal or not. Vignesh, it is clearly continuous, beta. Why is it not continuous? 0 पे right hand limit, left hand limit, both are 0. Why it should be discontinuous? It is x into mod x. Quickly find beta these two limits and see they are equal or not. It shouldn't be taking this much time, beta. It's easy. Yash, what is your LHD? Yash, what is your LHD, beta? Okay. And what is RHD? अच्छा, okay, तो उसकी जरूरत ही नहीं पड़ी. बेटा मतलब अलग ही फॉर्मूले लगा रहे हो तुम कुछ. बेटा, this is bad. Actually, मतलब I'm not feeling happy. मतलब it just makes me feel that I should not be doing the other coming questions. Yes, Vignesh. बेटा मतलब समझ नहीं आ रहा मुझे, मतलब how you get it undefined. F of minus h is minus h into mod of, very good Vignesh, mod of minus h, minus f of 0 is 0 upon minus h. Now this cancels out, so 0 per limit is 0. Yes, beta, I don't know which mathematics you are doing right now which makes your LHD undefined. For me, it's coming out to be very clearly 0. Yash, do not say calculation mistake. I don't think there is anything which should have been calculated wrongly. There is one step and you are saying that you have done calculation mistake. Don't argue now. Really bad on your part. So they are equal and hence function is differentiable. Okay. And guys, everybody look here. I'm really feeling very bad right now, but still I have to do this. I have to teach. Malab, real bad on your part. You couldn't do this simple question. And I'm expecting that I'll be making you doing the coming good questions. I just think I should stop this lecture here. I shouldn't be doing good questions with you right now. Well, I have to. Guys, let us see alternate method. We could apply shortcut method also here. Try to see if we open up mod. if we want to open up mod, we need to make two cases, x greater than equal to 0, x less than 0. When x is greater than equal to 0, this mod opens as x. So it is x into x. And when x is less than 0, this mod opens up as minus x. So x into minus x is minus x square. Clearly it is continuous, so we can write f dash straight away. It is 2x for x greater than 0. Equality should be removed. Minus 2x for x less than 0. Now clearly if you see left hand derivative at 0, it's 0. And right hand derivative at 0, again it's 0. So they are equal. Any doubt in this thing? Yeah, that's bad. You couldn't do this question. Perhaps I have started expecting more from you guys, but really poor. And Aryan, you just keep mum as usually you are. Anybody having doubt in this question, beta? Aryan, sometimes you have to give answers also, no? It's not only for listening thing you have come here. When I'm giving you some question, you have to answer it also. Sorry. We should better remember this as a result that x minus a into mod of x minus a is differentiable at x equal to a. Just like this, similar proof, exactly same proof. So you better remember this thing as a result. It helps in many objective questions. X minus a into mod of x minus a is differentiable at x equal to a. Now next is this question, fx equal to 4 minus x square ka mod. We need to check differentiability for all x. First of all, do you understand that whether it is 4 minus x square or x square minus 4, both means same thing? Do you understand that? It's mod at the end of day. So mod of a or mod of minus a, both are same. Can I write it like this? Neha, do you understand this thing or you have problem with this thing? Lalit, you also tell me, beta. Very good. So we need to check differentiability for all x. Now guys, the point is, first I should be knowing where I need to check differentiability. Okay. For that thing, you need to remove this mod. For that, you need to see where this thing is positive and where it is negative. Guys, we know wavy curve. So we know it is positive when x is outside minus 2 and 2, and it is negative when x is inside minus 2 and 2. So using this, I am opening up mod. When x is less than minus 2, the inside term is positive. So mod opens up as such. When x is minus 2 to 2, the inside term is negative. So mod opens with negative sign. And when x is greater than 2, my inside term is positive. So mod opens up as such. So first of all, in this question, we have to remove mod to see how a function looks like. And hence, I understand that I need to check differentiability at -2 and 2. Because about these 2 points, my definition is changing. Okay. So I can do this question in 2 ways. Number one is I'm doing it with shortcut. And of course, by now you understand that the basic definition. If in school you require, you can apply that LHD and RHD definition. Right now, let us practice shortcut. So straight away differentiating 2x minus 2x plus 2x. Guys, if you see at -2, my left hand derivative is -4, my right hand derivative is +4. Yes, beta, thank you. Clearly they are not equal, so not differentiable at -2. At x equal to 2, my left hand derivative is -4, my right hand derivative is +4. Again, they are not equal, so neither differentiable at x equal to 2 nor at x equal to -2. Elsewhere there is no problem at all. Guys, one alternate method which I should suggest you is, if you are good at graphs, guys, that is how a graph of x square minus 4 looks like. And if you want to plot its mod, this part will look like this now. This is -2 and 2. Clearly at -2 and 2 we have sharp points. And hence it is non-differentiable at -2 and 2. But this method is only for those who are good at graphs. Otherwise, just don't do it. It will not be like good for you because you will get stuck, no? So this is first method. This is second method if you are good at graphs. Certainly both the methods should not be applied in school. In school, you have to do it with proper LHD definition and RHD definition. Okay. Yes, Jan, we remove this equality when we differentiate straight away, because if we keep it like this, then it means that f dash at -2 will be found from here, because for x equal to -2, this is f dash. It comes out to be 4. So f dash -2 is 4. But it is not that. We just do not know the value at -2. We know that derivative basically what we use is that this is a, say this is any function. This is x, sorry, wait a minute. It is x square for x less than a and minus a square. This is how graph looks like. Now what we do is, we do not see derivative at a. We say when x is here, then the derivative will be coming from here, no? And when x is here, then the derivative will come from here, no? So we just find derivative to the left of a and to the right of a, like here. We do not find derivative at a directly because we do not know that. If we would have known that, why will we be taking so many things into picture? We just find derivative to the right and left of a, and from there we analyze. Got a rough idea, beta? Yash? Okay. Now this is important question from objective point of view also and school point of view also. For school and competition. Important. Why it is important? Guys, we have done such questions in continuity also, where it was given that it is continuous and we had to find a and b or m, anything like that. In differentiability also we have such questions. Now the point is, why I'm drawing line? Students use only half information. Being differentiable, left hand derivative at 1 should be equal to right hand derivative at 1. Sorry, minus 1. Yes. But in school, you find these derivatives properly by definition. Here I'm doing it by shortcut. So f dash x is a for x less than equal to minus 1, sorry, less than minus 1, and 3ax square plus 1 for x greater than minus 1. Therefore, LHD equal to RHD implies a equal to 3a plus 1. So a equal to minus half. Anybody having doubt in this thing? We just equated LHD with RHD and nothing else. You understand this much? Very good. But we only got A. What about B? We used the complete definition of differentiability, but we got only A. We didn't get B. And that is where the importance of this question comes into picture. Being differentiable, it's also continuous. So you also have to use continuity. Therefore, left hand limit at minus 1 will be equal to right hand limit at minus 1. This is the point which is important. So in such kind of questions, along with differentiability, use continuity also. From there you will get one equation. So left hand limit at minus 1 minus a plus b, and right hand limit at minus 1 is minus a minus b 1 plus 2b. Cancels out, so b equal to 1. Hence you have your answer. So in differentiable questions of this type, you use continuity also to get one equation, and another equation you get from differentiability, and then they combined give you answer. So guys, just tell me, did you understand what I want to tell you through this question? So whenever we use differentiability in such question, we also have to use continuity along with it. So guys, can you do this question now? Simply, easy. We use continuity at C, we use differentiability at C, we get two equations, we get A and B, and we are happy to go. Just note it down, this is your homework. I have given the answers in the next slide. Okay. Now, we are going to do now mixed questions, like the questions you'll be facing in objectives type of questions. No, there one thing is very important which I've marked with the red color. Read it. This is a very important point. Same as continuity. A bad thing when added with good thing makes it bad. Okay. Good and good will obviously give you good thing. Bad and bad can give you anything. But bad and good, when added, will always give you bad thing. Keep that in mind. It will help you a lot in objectives, because in objectives, no, the options will be like it is differentiable at this point, it is non-differentiable at this point, it can be differentiable. No, these are the points where it is non-differentiable. So in objectives, primarily you will face trouble with which points do we need to check. This thing will help you a lot in that. Let us do some questions. This is the first question, and it is really good question. Check differentiability of this, and we are not told at which point I need to check. I need to see that myself. Okay, that's the points where I need to check. Obviously, I am assuming you know that. Let me still write it. Polynomials, log, exponential, sine, cos, etc. are differentiable because they all are smooth functions. We know their graphs are smooth. Yes, mod of x minus a, gint x, तो discontinuous ही होगा, तो obviously it is not differentiable, is not differentiable at x equal to a, because we know the graph of mod of x minus a, it looks like this. So it has a sharp point at a. So mod of x minus a is not differentiable. It is continuous, it is connected, but it is not differentiable. These two things we need to keep in mind. Let us start examples. Try to see, when I see this question, first thing I'm going to do is I'm going to just simplify it as much as I can. Now you just see how I first note down the points where I need to check differentiability. That is a point where my function might get non-differentiable. How I just reduce that. Number one, this is telling me 0 can create problem. Not for school. This is telling me 0 can create problem because mod x is there and mod x is non-differentiable. So it clearly can create problem. I will not say it will create, it can create. Okay. We know the property of mod breaks over multiplication. So let me write it like this. So x equal to 2 can create problem because we have mod of x minus 2. X equal to 1 can create problem because we have mod of x minus 1. The rest we do not have any point to be worried about. Any doubt in that? Very good, Neha. Anybody having any doubt? So these 3 points are the points which I need to worry about. Now just try to see how I further reduce them. Guys, in the beginning only we today learned that x minus a mod of x minus a does not create problem. It's differentiable. Remember that? Today only we did that when we proved x mod x is differentiable. So 1 is now not creating problem. Okay. 2 is still a point of worry. 2 is still a point of worry. Now, guys, cos of mod x is cos x. Why? Beta, because if this mod opens up with plus sign, then though it is clearly cos x. And if this mod opens with a negative sign, even then we know cos of minus theta is cos theta. So in both the cases, it will come out to be cos x only. So cos of mod x is cos x. Hence, 0 is also not a point of worry. Do you understand that? Very good. Okay, very good. Very good, guys. Very good. Now the last step. In objective, that is how you are going to approach. First, you will mark the points which might create problem. Then if using some fundamentals, you can reduce it. And now in the end, the main point, just try to see. This is non-differentiable at 2. Rather, if you see carefully, this is not differentiable at 2 because this is non-differentiable and the rest of the part just cannot make it beautiful. This sharp point can only be removed when either I increase its degree or I multiply it with 0. Otherwise, it cannot be removed. So that is how you have to think about it. That first complete term is non-differentiable at 2, whereas this is differentiable at 2. It is differentiable everywhere. So guys, as I told you, a bad thing when added to good thing makes a bad thing. So fx is non-differentiable at 2. Guys, if you just manage to understand this question, no, in the real sense, the way I'm trying to explain, then let me tell you, I'm not going to face any problem with objectives. It is this strategy or this way of thinking only which you require in objectives. So that is all I just wanted to convey through this question. So even after the lecture, try to see this much session for 2-3 times and try to take as much as possible through this question. Very important concepts, little but very important concepts when it comes to objective. So I just didn't do any work. I just didn't find an RHDL. Beta pagal ho jayenge if you just cannot find RHD, LHD for such a big expression, no? Just by mere basic fundamentals, I deduced that x equal to 2 is the only point where my function is might create problem. And then using another fundamental, I just said authoritatively x equal to 2 is a point of non-differentiability. That is all you have to learn. Okay. Guys, now this is a kind of subjective question, important for school also. I mean, it is given in some of subjective books. We have to find f dash k positive. By the way, it means derivative to the right of k. So it is short form for this. Right hand derivative at k ko we in short we write f dash k positive. So question seems to be easy. It is simple definition based question. Then what is so good about it? Good thing is little bit of trigonometry will be used. Try to see. When we write f of k plus h, what will be f of k plus h? Gent of k plus h sine pi k plus pi h minus f of k, gent of k sine of pi k upon h. First basic concept, guys, k is integer and sine at n pi, where n is integer, is 0. Sine pi, sine 2 pi, sine of n pi are all 0. So this term reduces to, now this is, so I can clearly assume that gent of k plus h is k. Minus 0 upon h. This much is left. Just have a look. चाँद छुपा बादल में शर्मा के मेरी जान से लगे जाती खाके मेरी जाना टुम 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 टुम. Okay, so moving ahead, Neha, sine of n pi, where n is integer, is 0, and here k is given to be integer. So sine of k pi will be 0. Is it okay now? Okay. Now guys, one thing, let me just try to recall. Sine of pi plus theta is minus sine theta. Sine of 3 pi plus theta is minus sine theta, and so on. Sine of 2 pi plus theta is sine theta. Sine of 4 pi plus theta is sine theta, and so on. When it's odd multiple of pi here, then we get minus sine theta, because that angle will lie in third quadrant where sine is negative. And when it's even multiple here, then it is sine theta. You remember this much trigonometry, beta? We just did inverse trigonometry. Don't you say no. Okay. So that is the base for simplifying this term. Now just see this thing as theta. Now this is k pi. Now if k is odd, then this thing should become minus sine pi h. And if k is even, then it should become plus sine pi h. But we don't know whether k is even or odd. So how to take both cases into account now? Nothing. Minus 1 raised to power k, like this. Try to see if k is odd, this will become minus, and when k is even, this will become plus. Just have a look. Did you understand how I just did that? Sine of k pi plus theta is sine theta with plus or minus sign depending upon k is odd or even. So I just inculcated that thing like this. And now it's very easy. I'll multiply, divide by pi, so that this is sine of 0 by same 0, and hence it becomes 1. So my answer is minus 1 raised to power k k into pi. So that is all about this question. This is important for school as well as competition. Now, next definition is differentiability in an interval. By the way, this definition is not in school. Differentiability in an interval is very basic, like continuity only. Same definition. It is differentiable in open AB if it is differentiable any point inside AB. Same definition. And closed के लिए भी same. It is differentiable in closed AB if it is differentiable in open AB. It is right differentiable at A. It means the right hand derivative at A is finite. It is left differentiable at B. That is left hand derivative at A is finite. That's all. So there's few basic questions which you can do it even yourself also. We have to check differentiability in open 0 to 1, closed 0, open 1, open -1 to 0, closed, and all. Normally these questions are not asked. I just took this example here to make you apply the definition. I'm doing it orally first of all. First part, I know I need to check the things at 0 only because, sorry. Okay, when I'm seeing 0 to 1, I need to see function between 0 to 1. And when I see function between 0 to 1, it is x cube plus 2. Try to see for x greater than equal to 0, this is my function. Being polynomial, it is differentiable. It is differentiable. Issues khatam, finished. Then comes closed 0 to 1. Guys, open 0 to 1, I have checked already. I have given you the argument. Here, in addition, I need to check LHD at 0. That's all. And by the way, you can easily find that using definition. I have done it for this case. Okay, yeah. Sorry, LHD लिख दिया मैंने. Oh, sorry, RHD. RHD at 0. So you find RHD at 0, applying definition. It comes out to be finite. Hence, done. So this definition doesn't make any sense. It's a very simple thing. So nothing special about this thing. It's just for your records that yes, this is a definition. Nothing more than that. So guys, can you easily do all the parts of this question? Very good guys. So just a basic definition, nothing else you have to apply. I've given the solution also. I've given all the solutions here. Now guys, as such, chapter is finished. Totally finished. There are few problems, as you know, at the end of chapter we do miscellaneous problems. And you know I don't do them, I just give hints for them. So I'll give you hints for next 4 or 5 problems. You have to give a good thought on those problems. They are primarily mains plus or advanced level. So if you have any doubt, you may ask me on WhatsApp. So let us start. Read the question. These are mixed question on continuity and differentiability. I need to check continuity of fx, where fx is defined this way. Beta, only those students attempt these questions which are pretty confident in continuity differentiability now. Rather, you attempt these questions after practicing from objective exercise. Do not attempt them straight away. I'm just giving you hints so that when you attempt it, you know the direction. Guys, if you remember in 11th class, in parabola, you did parametric form, x equal to 80 square, y equal to 280. Do you remember that? Parametric form of parabola. Okay, very good. Guys, given a parametric form, you can always tell what is the function. And how do you tell that? You eliminate t from them. Eliminate t. Like x equal to, from here you say t equal to y by 2a. Put it here, a y by 2a ka square. It is x equal to a y square by 4a square. So it is y square equal to 4ax. So if y equal to fx is given parametrically, then you can get equation of fx by eliminating t, just like I did here. I found t from here in terms of y and put it here. So t got eliminated and I get equation of curve. So this is basically primarily a part of locus. If a curve is given parametrically, you want to know the equation, just eliminate the parameter. So guys, here that is a problem. We are given the curve parametrically form, but we need to require the equation. So you have to eliminate t. And then you will get equation. Equation you can check easily that if it's continuous or not. Now the point is here elimination of t will not be that easy because mod is involved, so it will disturb you. But direction yahi hai, you have to eliminate t. Once you eliminate t, it is very simple question. So I have given the solution here. You can see it later on, but after you attempt it. Okay. So when you simplify it completely, you will get your fx to be this. When you eliminate t completely, this is like a really good question, advanced level types. When you eliminate t, this will be your function. And once you get your function, you know you need to check continuity at -1 and 2. So primarily question is not at all tough because of continuity. It is tough because of the function which is to be checked for continuity is given in very bad form. To bring that into a good form is the tougher part of question. Once you get fx, it is very easy to check continuity. So continuity is simple in this thing, but that simplifying process is really complicated. So you need to see that. Okay. Next is this, check differentiability of x upon 1 plus mod x. Guys, obviously by now you know that only 0 is my point of concern because mod x is there. So x equal to 0 it is non-differentiable is point of concern. Now it is an easy question. You just find RHD and LHD, and if they come out to be equal, it is differentiable. If they don't come out to be equal, it is non-differentiable. Out of the records, but you can keep it as a note that mod x in denominator is okay. It's fine. It's differentiable. So had I been doing this question in objective, I would have written, but as mod x is in denominator, so no problem. But of course, there's no any theorem or result like that. It is just a mere observation. Normally, it does not create problem in that denominator. Okay. Solution is given, which you can certainly This is like not a tough question at all. Next is this question. Again, it is important, easy and important. Not easy like very easy, but for competitions like mains plus level pay, it is standard. Find minimum value of m for which fx is continuous. Guys, definition. Limit should exist and it should be equal to value of function. Apply this thing and you get your answer. You better do this question without seeing the solution. Okay. Then second part, find minimum value of m for which fx is differentiable. Guys, again, definition. Do not apply shortcut here. It is of the form x not equal to a, x equal to a. So do not apply shortcut. Apply definition. RHD likho, LHD likho. They should exist and they should be equal. Okay. And चलो यहाँ पे solution साथ ही दिया हुआ है. C part. Find minimum value of m for which f dash is continuous. Now this is somewhat different. How will we find f dash? Guys, here you need to understand when you write f dash. First you need to write f dash, only then you will check its continuity, no? So when you write f dash, for x not equal to 0, so you differentiate this thing directly. Differentiate. But for x equal to 0, you know you cannot find derivative straight away because x not equal to a, x equal to a. So here find f dash 0 by definition. That is, write RHD, write LHD, and they should be equal. From there you get f dash 0. And whatever f dash you get, check limit. If limit exists and is equal to f dash 0, that it is continuous. You better name f dash as something or you will get confused again and again. Okay, so you just name f dash to be gx. So gx is continuous if limit is equal to value. These are few questions which you just do. If you do like carefully, then you will be really good at differentiability. And this is the last example. If this is differentiable at 0, find a and b. Guys, प्यार से समझ लो, it is also there in objectives. Well, such questions are there in objectives. We will not do any computation, just logically we will approach it. It is differentiable at 0, find value of a and b. Guys, try to see one thing. This is so non-differentiable at x equal to 0 because of mod x. And if you remember the graph, this is e power x. And if you want to make the graph of e power mod x, this is removed and this is here. If you want to remember the graph of e power mod x. If you don't remember the graph of e power mod x, then you better check it by definition. That right hand derivative, left hand derivative of e power mod x are not equal. So e power mod x तो non-differentiable है at x equal to 0. Talking about b mod x का square, guys, mod x का square is same as x square. Now this is so differentiable at 0. Now guys, old fundamental. A bad thing when added to good thing, it will make it bad. So when we will add these two things, they will become non-differentiable at 0. But we want it to be differentiable at 0. So it will be differentiable at 0. Very good, Vignesh. Only if a is 0. This term has to be removed. And by removing the term, we mean its coefficient must be 0. B can be anything. B is not making any difference. You take B to be anything. So this is the answer. So with that, signing off. Continuity differentiability finished. This is a syllabus for your coming phase test, I suppose. I'm not very sure. No, yours batch is something different. I don't know, but I suppose this much is a syllabus for your next phase test. So you start doing practicing limit continuity differentiability. All the concepts are done. Send me your doubts. Just finish all the tutorials, your subjective book. Okay. So order should be finish tutes. This is first thing. Second, finish subjective book. This is second order. And third order is objective exercise. Just complete it.